This is a demo of the Language Interpretability Tool, or LIT. This open source tool is built to allow users to easily demonstrate and analyze NLP models on a dataset. LIT allows users to interactively ask and answer questions like, what kind of examples does my model perform poorly on? Why did my model make this prediction? And how does model prediction change if inputs are perturbed? I'll be demoing it with a BERT-based binary classifier on sentiment analysis, with the positive class being positive sentiment, using the Stanford Sentiment Treebank dataset of statements from movie reviews. Although this tool works with a variety of model types, including regression, multi-class classification, seek-to-seek, and structured prediction, and is extensible beyond that. The top center view shows the evaluation set in a searchable, sortable data table. In the top left is a view of the dataset by their embeddings returned by the model at various layers. The embeddings can be projected down to 3 dimensions by PCA or UMAP. In this case, we're looking at a UMAP projection from the output layer and can clearly see 2 clusters. The data points are currently colored by their ground truth sentiments, and it seems that each cluster corresponds roughly to the class that the model thinks each data point is in. You can select data points to inspect from one of many components, including the data table, embedding projector, or the prediction score jitter plot in the lower right that is showing all points organized by how positive the model scores its sentiment. Now, if I select a set of data points, we can see them highlighted in the other data set visualizations. We can use one of these as our primary selection and see its details in the data point editor in the top right. Here we can edit this data point to create a new data point, which is tracked as a child of the original one for data point provenance. In the bottom left corner, we can see detailed model outputs for the primary selection. In this case, the score for each class of the classification model. The bottom section of the tool contains tabs to dive into different analysis types. In the Performance tab, we can see our model's performance across the dataset through standard metrics. We can compare this to the metrics for our selection, and also across a set of dataset slices. In the top toolbar, you can also save selections you care about as named slices for future use. This tab also contains a configurable confusion matrix that can be used for data point selection. In the Counterfactuals tab, we can take data points of interest and create counterfactual versions of them through a user-extensible set of data point generators. In this case, we'll use the word replacer generator to take selected data points and perform targeted replacements in those. We can then add those counterfactuals to our dataset and explore how model behavior changes with these edits. We can compare the outputs from a data point to its counterfactual with just one button click. Note that we can also compare the predictions of a single data point across multiple models through the same comparison UI, although we don't demo it in this short video. If we move to the Explanations tab, we can look at model behavior beyond just prediction results. The center contains token-based salience maps for individual predictions using a variety of techniques to get token importance, including LIME. The right side contains attention information, showing for each attention head at each layer which tokens were used to create the results at that next layer. Individual modules can be expanded to full screen to get a better view. This has been a brief tour of some of the features of the Language Interpretability Tool. The tool is under active development, and we plan to continue to expand its capabilities, refine the UI, and look forward to any external contributions and feedback as well. Thanks for watching.